This is Mr. Beck Does Your Homework. This is AP Physics, Homework 3.1 on balanced forces, question number 7. This is a very good vector addition problem, and this is a vector addition problem where the result must be 0 so that this thing stays balanced. So, the 9.2 Newton weight, that must be this thing, 9.2 newtons, so that's down, is in equilibrium under the influence of the 3 forces acting on it. The F force acts from above on the left, that's this one, at an angle of alpha. Hey look, it's not beta, that's great. At an angle of alpha with the horizontal. So there's that force in that angle. The 5.2 Newton force acts from above on the right at an angle of 47 degrees with the horizontal, so that's this one. The force 9.2 newtons acts straight down. What is the magnitude of the force F? And then what is the angle of the force F as shown in the figure? So if this is in equilibrium, then I know that my up must equal my down in terms of magnitude. I also know that whatever I have left must equal whatever I have right. So I've got 9.2 straight down. Well, that's a down. I could even write my 9.2 right now. And I've got 5.2 at 47. I don't know what that is. Well, 5.2 at 47, is that up and down or left and right? It turns out it's a little bit of both. So if I take my 5.2 at 47 degrees, at an angle of 47 degrees, then that could be a force in the x direction and a force in the y direction. My y direction will be up, so that is going to be 5.2. It's opposite the angle, so it's going to be sine of 47. So that is going to go here, as up is 5.2 sine of 47. Do I have anything else pulling up? Sure I do. I've got this force pulling up at an angle alpha. I don't know what that is. So that is going to also have my force of F in the y direction will be my pull up. So this is this plus this equals this. Left equals right. What do I have left and right? Well, I've got this x to the right, and that's going to be my 5.2 times the cosine of 47. It's my fx. And I also have this force, which is pulling in the other direction. That's going to be left. So right, I've got 5.2 cosine 47. And to the left, I've got this force in the x direction. So I've got a force in the x direction equals 5.2 cosine 47. I've got a force in the y direction plus this equals 9.2 newtons. So this is neat because I will wind up with an answer for fx. And that one is pointed in this direction, right? This, if I take 9.2 minus 5.2 sine 47, I know that my fy is going to be that answer, 9.2 minus 5.2 sine of 47. That will give me an fy equals something or other, and I can see this is pulling up. So now I know my fx is a number right there. I know my fy is a number there. So now I want, what is the magnitude of the force F? Well, these are the two components of force F, so I know that they're going to add to some force pulling up in this direction, right? Well, this one is, if I slide the y over, then I've got myself a right triangle. So I'm lining up my components head to tail to get my total vector. And now if I know fx and fy, I can get that using my Pythagorean theorem, or Pythagorize. A squared plus b squared equals c squared. And c is what you're looking for. So a is going to be fx squared plus fy squared equals my f total squared. So square root those, and I get myself my force. Question 8 says, what is the angle of the force as shown in the figure? Well, I'm looking for this angle. If I want this angle, and I know this, and I also know this, I can use any inverse function to figure that out. Since I know fy and fx more directly, I'm going to use those. And I know that the tangent of the angle, it's not theta, in this case it's alpha, so the tangent of alpha is going to equal the opposite over the adjacent. So that's fy over fx. So if you plug in your fx and your fy, you will get a number. And that's the tangent of alpha. So alpha is going to be the angle whose tangent is Fy over Fx. And I've solved myself for my magnitude here and my direction here of this force.